All right, so this video is all about Chapter 3, and we're going to be looking at what's called a contingency table. Contingency table is just the stats name for this table we're used to seeing in our lives. It looks like we're gathering data about two variables. The first variable would be gender, keeping track if someone is male or female. And then it looks like the second one is kind of transportation. The question was asked about how do you get to school. So some people arrive by bus, some people get a ride, some people bike or walk. So when you see a contingency table, if it doesn't have totals in already, that would be something really helpful to include. So I'm just going to simply count up the number of males. I get 86 if I add those all up. Count up the total number of females. There's 102, which gives me 188 total. And I can do the same thing going across. If I want to know how many people ride the bus, there's 30 boys plus 34 girls, so that's 64. I can think about ride. That's 82, and 42 make their own way. And if I add these up going down, I also get 188. So one of the things you might be asked to do with a contingency table is identify what's called a marginal distribution. The word distribution, I think of when your teacher distributes your papers. Your teacher is passing out the papers. So distribution is simply how things are distributed or split up. The margins are the things that are not in the table. They're not inside this table I've drawn. They're in the margins. Margins. Outsides, right? Outsides. So when I ask for the marginal distribution of transportation, I'm looking for what's in the margin as far as transportation. So transportation, my choices are bus, ride, bike, or walk. And here it is, out in the margin. This is how it's split apart. I'm not worried about male, female. I just care about how people get to school. So I'm just going to write down 64 take the bus, 82 get a ride, and 42 bike or walk. And that's it. I'm just explaining how transportation is split apart. It's marginal because I'm looking in the margin. All right, the next one asks for the marginal distribution of gender. So as you might imagine, we're looking at the margin for gender. I don't care about how they get to school. I'm just interested in how many males and females there are. So it looks like there's 86 male, 102 female. And I've just described the distribution, or how it's split apart. So another thing that you'll see asks for relative marginal distribution. So same idea, but we're going to put this relative piece in it. It's just a percent. We're keeping it relative or compared to the total. So again, if I'm thinking about the distribution of gender, the marginal distribution, I'm looking at the margin here. And percent, well, I'm just going to calculate the percent of each gender. So there's 86 boys out of 188 altogether. I should punch that in my calculator to get my answer. I got roughly 45.7%. That's boys. Do the same thing to calculate girls, 102 out of 188. I got 54.3%. Those are girls. So this explanation right here, that's my relative, because it's in percent, marginal, I'm looking at my margin, distribution of gender, how gender is split up. By the way, if you struggle getting these things into percents, please send me a message. There is an Algebra 2 prerequisite for this class, but I know some of you over the summer you just block some things out. So be sure to send me a message if you need some assistance converting to percent. All right, there's another thing that you might be asked about. We saw marginal distributions already, but now we're going to take a look at conditional distributions. Condition is like a requirement or a piece of info that's already known. So when I talk about the conditional distribution, there's going to be a requirement or something that I tell you ahead of time. Notice we're still doing relative So our answers will be in percents. And we're going to look for the distribution, so how it's split up for modes of transportation. So we're going to be considering transportation, people bus, ride, or walk. And it says specifically boys. Boys. That's my condition. That's my requirement. That's my piece of information that's already known. I only am going to look at the boys. All right, now I'm going to see how boys are split up based on their mode of transportation. All right, there were 30 that bus out of 86. Notice I'm using this total because I only am worrying about boys. I'm not using the total of everybody. And if I write that as a percent, because I was asked for a relative frequency, that's 34.9%. And that's that takes the bus. There were 37 out of 86. That makes about 43% that get a ride. And 19 out of 86, or 22.1%, that walk or bike. So again, this information here, this is my conditional relative frequency for transportation of boys. Again, because it said boys, I ignored the girl part altogether and just focused on how transportation is distributed or split apart for boys. All right, while we're talking about percents, you will often be asked just percent questions. Kind of some building blocks for probability, which we'll study at a later time. I have 4 questions listed up here. They are very, very similar, but they all have different answers. So what we're going to focus on here is reading carefully. So the first question says, what percent of students are girls? Well, I want to know how many girls there are. Looks like there's 102 out of the total number of students, 188. And it does say what percent are girls, so I'm going to list that as 54.3%. Now, slightly different question. What percent of students are girls who rode the bus? So now I'm looking for girls who ride the bus. Well, if I look on my chart, females here, so it's going to be one of these 3, and ride the buses here, so it's going to be one of those 2. 34 is where I have both. They ride the bus and they're female. So that's 34 out of all the students. So that's 18.1%. The next 2 questions is where students tend to get a little bit more confused. The third question says, what percent of girls ride the bus? Not the same question we just answered. This is what percent of girls. This is a conditional question. I'm giving you a condition or a requirement. I'm only going to focus on the girls. So I'm looking specifically at this section here in blue. So since it's of girls, I'm going to put my denominator as 102. That's the requirement. It has to be a girl. And then I'm looking for, well, somebody who rides the bus. Well, that's this 34 here. And listed as a percent, 33.3%. All right, I'll do the next one in green. What percent of bus riders are girls? I get, Miss Curtis, didn't we just answer this question? No. This time we're what percent of bus riders. So I'm only concerned about people who ride the bus. By the way, drawing on tables can be very helpful to kind of keep your focus a little more narrow. So this one, it's going to be out of 64, because I'm only concerned about people who ride the bus. And now the question is, well, what percent of them are girls? There's 34 girls that ride the bus, so that gives me 53.1%. Please use caution when answering questions like this. They'll try to trick you, and specifically, they'll try to change the wording around a little bit. So big idea here, read carefully. All right, there's one last idea on contingency tables. I know this is a lot to think about. Last idea is to think about independent or independence. And the definition given to you in your textbook says when the distribution of one variable is the same for all categories of another. And I know that sounds crazy to listen to, so let's focus on that definition maybe a little bit later and think about variables in, or independence in the way that you've maybe heard the word used before in English. A lot of times I hear teenagers say, well, I can't wait till I'm independent, right? Independent of my parents. You want to be out on your own, so your parents don't tell you what to do. So that means that two things are not associated, or I think of right, not influencing. Influencing. The last thing that you're going to see with contingency tables is this idea of independent. And the definition given in your book says when the distribution of one variable is the same for all categories of another. That doesn't really make sense right now, so let's think of the word independent like you might use it in conversation. I can't wait till I'm independent of my parents. Right? The idea is your parents no longer tell you what to do and where to be. You're living on your own. You make your own decisions. So the other definition I have here is that two variables are not associated, or I like to think of as not influencing. Right? If you're independent of your parents, they don't influence your decision. So if I'm looking for two variables to be independent, they don't influence one another or affect one another, or they're not associated with one another. So what we're going to do here is we're going to compare the conditional distributions. In order to find out if gender and mode of transportation are independent variables, we're going to compare their conditional distribution. We did the conditional distribution for males back a couple slides ago, so I'm just going to fill those in. When we focus just on males, we found these percentages. 34.9% rode the bus, ride, walk, etc. So now I'm just going to do the same thing for the females. I'm going to focus in just on the females, and I'm going to find those percentages. So each of these is going to be out of 102, because that's my total for the girls. And I'll just jot down those percents. I worked these out ahead of time. So those are my percents. So my job here is to compare them. The definition says when the distribution of one variable is the same for all categories of another, two variables are not associated. So what I'm looking for is, are these two things the same? So I'm looking for equal percents. Well, 34.9% and 33.3% are certainly not equal, but they're pretty darn close. In stats, we very seldom get equal because we're sampling. It's an imperfect process. So we're going to go with, or pretty darn close. If we look at riding, getting a ride to school, there's 43% of boys that get a ride, 44.1% of girls that get a ride. That is pretty darn close. Look at this last one, 22.1% and 22.5%. That is pretty darn close. So when they're the same, that tells me my two variables are not associated. Another word for not associated is independent. So what I've discovered here is that my two variables are, yes, independent. That kind of makes sense to me. Certainly what gender you are is not going to influence how you get to school. Makes sense. All right, so that concludes what we need to learn about contingency tables.